Dear students, welcome to another lecture of Module 6. In this lecture, we are going to discussing about the tropospheric scatter propagation, different fading techniques and different diversity techniques. Okay, we shall see the first topic, that is tropospheric scatter propagation. Tropospheric scatter propagation is a mechanism by which the propagation is possible by the scattered and diffracted rays, and this scattering takes place due to the tropospheric region. And the tropospheric scatter propagation is also known as forward scatter propagation, and it is important at the frequency range from 160 MHz onwards. That is, it is important at very high frequencies and ultra high frequencies and microwave frequency ranges. And this mechanism helps to unexpectedly large field strength at the receiver even when they are in shadow zone. That is, they are in tropospheric region. The electromagnetic waves are generated by high power transmitters. That is very important. In this type of propagation, the transmitting antenna that we use is a high power transmitting antenna is used here with high gain and directivity, with high gain and directive antennas to reach the upper layer of troposphere. And the scattering of waves take place due to the considerable variation of refractive indexes, and the scattered wave reaches a receiver as shown in figure. That is, this is a transmitter and this is a receiver, and this wave is transmitted to the tropospheric region, and this is a tropospheric scatter region, and this region, this wave is scattered wave that is reaches to the receiver side, and this propagation cover the long distances in the range of 160 to 1600 kilometers. So this mode, that is this propagation, uses the properties of troposphere, hence by using scattering mechanisms. Hence it is also known as tropospheric scatter propagation. This is another figure showing tropospheric scatter propagation. So this is a transmitting antenna. Here we use high power transmitting high gain directive antennas for transmitting the wave electromagnetic signals to the troposphere, and this transmitting antenna transmit the signals, and this region is called scattered region. This region is called scattered region, and some rays is reflected back to the Earth's surface and some rays is reached to the receiver, and this rays is called forward scatter, and the some is no scattering and it is going outward. This is no scattering, and this is some losses of signals. This is the figure for tropospheric scatter propagation. Next, let us see what are the advantages and disadvantages of this tropospheric scatter propagation. The main advantages of tropospheric scattering is, as compared to the normal radio links, the number of stations required to cover a large distance is very small, and it provides reliable multi-channel communication systems and the better performance in a crowded area, and it requires less maintenance than the line of sight communication systems. Next, we shall see the disadvantages, and the system is found to be very expensive, and the radio link path suffers tremendous loss. Okay, these are the disadvantages of this tropospheric scatter propagation. Next, let us see what is fading technique. Okay, then fading. Fading is, what is mean by fading? That is, fading is the changes in the signal strength at the receiver, and the main causes of fadings are the variation in the ionospheric conditions and the multipath reception. Then we transmitter side the signals transmit different path receiving side receiving side signals correct transmit signal correct frequency of signal in the receiver understand. So due to multipath fading, and the main causes is multipath reception and the variations in the ionospheric conditions. That is, the ionosphere is not stable. Ionosphere that consisting of different electron densities and small path changes. Hence, there will be a changes in phase, and this causes the receiver signal strength to change. And there are different types of fading, that is multipath fading, selective fading, interference fading, absorption fading, polarization fading, and skip fading. Multipath fading means, as its term implies, multiple paths of a radio waves follow between the transmitter and the receiver. Multiple paths follow between the transmitter and the receiver. So the such propagation path includes ground beam, ionospheric refraction, re-radiation by the ionospheric layers, and the reflection from the Earth's surface or from more than one ionospheric layers, and so on. and this figure shows a multipath fading. So this explicit communication, consider this X is a transmitter and Z is a receiver. So in this explicit communication, one path is XYZ and the another path is XFZ and the another, so these two paths. So at the receiver side, the signals reaches the receiver side to different paths. So at the point is this received signal is a combination of this ground wave and this sky wave. So these two signals have different path and that arise at the point Z at different times. So thus arriving different paths So these two signals travel in different path and arrive the point at different times. So thus arriving waves may or may not be in phase and with each other. So the similar situation is results at the point A, that is one path is XEA and another path is ZFAs. One is through E layers and one is through F layer. This is multipath fading. Okay, next is selective fading. That is fading resulting from the multipath propagation varies with the frequency, since each frequency arrives at the receiving point by different radio path. So when a wide band of frequency is transmitted simultaneously, each frequency will vary in the amount of fading, and this variation is called selective fading. The selective fading occurs all the frequencies of the transmitted signals do not retain their original phases and the relative amplitude, and this fading causes distortion of signals and limit the total signals transmitted. And next is interference fading. It produces interferences between rays and by the interferences between the waves received at the receiver through different paths. It occurs due to the fluctuations in the layers, and the interference fading can be reduced by using the diversity techniques. Next is absorption fading, and this takes place due to the absorption waves of by the ionosphere. And the polarization fading, that is changes in the polarization of electromagnetic waves. Next is skip fading. This occurs near the skip distances, that is the variation of height and the density of layer causes skip fading. This can be minimized by using AGC at the receiver. AGC means automatic gain control unit at the receiver. Okay, next we shall see the different diversity techniques, and the fading can be reduced by using the different diversity techniques. These are frequency diversity, space diversity, and polarity diversity and the time diversity. Frequency diversity means the transmitter sent two or more frequency simultaneously with the same modulating information. That is, the transmitter sent. So here we are using two transmitters. That is, the transmitter send two or more frequencies simultaneously with same modulating information, and different frequencies will fade differently. One will be strong always. So different frequencies will be fade differently, and the one signal will be strong always. So this is the frequency diversity techniques that is used to reduce the fading. And the another technique is space diversity. Here a single transmitter is used. And at the receiving side, two or more receiving antennas spaced at 1/2 wavelength apart, and the signal will fade at one antenna while it increases at another antenna. Here one transmitter is used, but at the receiving side two or more antennas are used for receiving the signals. Okay, this is space diversity. Next is polarization diversity. Here the vertical and horizontal polarized antennas are used to receive the signals, and the two receivers are combined to produce a constant output. And the next is time diversity, that is a TDMA. This same signals are transmitted at different times. That is, as the fading is time dependent, some signals may be strong and fading is less. That is time, diversity. Okay, these are the topics discussed in the lecture, that is tropospheric scatter propagation, fading techniques and different diversity techniques. Okay, thank you.